So this is the first quarter update report that we just are putting together to finalize this study. And let me kind of give you an overview of what's going to go on. We started this project in May 2015 with two students, two PhD students. One is Zili Kwan, who's structural PhD candidate up there at UAF, and the other is Fang, and he's worked with me a number of years on structural health monitoring. And both of these engineering students are very, very active on this project. So it's an opportunity for them to look at a very significant structure in this country and to do something pretty exciting. The Zili Kwan, the top student, is just getting ready to conduct his PhD work on trying to model fires. So this will mean more to you as I begin to talk about this study a little bit. So let's talk about the study. The history of this work is the WTC-1 and WTC-2, those are called typically the Twin Towers, were struck by a commercial jet airline on September 11th, 2001. My wedding anniversary. On the buildings not struck by planes that suffered damage were WTC 4, 5, 6 that were damaged, and WTC 7 collapsed. Now, so there was things that happened here that a lot of people don't really often hear about. So the World Trade Center complex, a project was developed by the Port Authority of New York and New Jersey. Port Authority is typically what it's called, a bi-state public agency. Original occupancy of the towers was dominated by government agencies, including substantial occupancy by the Port Authority itself. In 2001, however, the predominant occupancy of the towers was by commercial tenants, including a number of prominent financial and insurance service firms. So that was the complex. This is the facility. Kind of gives you some idea of the WTC, WT1, WT2, and those are the twin towers. And we'll see here that you can see from the picture that WTC7 is part of that complex. A little bit better view of it will be shown to you in a moment. This is what we've all been struck by, is the remembering the planes that struck the Twin Towers, WTC 1 and 2 after impact. So the first one up there at 8:45 a.m., Flight 11, struck WTC 1. The building collapsed in about 2 hours later. WTC 2, Flight 175 flew into it around 9:03, and it collapsed at 10:03. So it kind of gives you some idea of those two buildings. The WTC towers 1 and 2 were primary to a 7-building World Trade Center complex. Each tower was 110 stories above the plaza level and 7 levels below. So WTC 1, the north tower, had a roof height of about 1,368 feet. It also supported a 360-foot tall television and radio transmission tower. WTC2, however, the south tower had a roof height of 1,362 feet. Each building was nearly an acre of floor space that provided at each floor level. A rectangular service core with overall dimensions of approximately 87 feet by 137 feet was present at the center of each building housing, with 3 exit stairways, 99 elevators, and 16 escalators. So it kind of gives you an idea. It was a very significant complex. Overall, if we take a look at this picture, you'll see where this study is actually working at. WTC 7 is sitting out here. The blue is a deep foundation area. In other words, WTC 1 and WTC 2 were over an area that had what we call deep foundations. The other area to the right, which is WTC 5 and 4, was shallow foundations, and WTC 7 was actually built over a complex substation. WTC 4, 5, and 6 were 8- and 9-story buildings, steel-framed office buildings located on the north and east sides of the WTC complex, and they were built by Serica in 1970. Because of the close proximity to WTC 1 and 2, all three buildings were subjected to severe damage, impact damage when the towers collapsed, as well as fires that developed from the debris. So most of WTC 4, for example, collapsed when impacted by the exterior column debris from WTC 2. The remaining section had a complete burnout, and WTC 5 and 6 were impacted by exterior column debris from WTC 1, and that caused large sections throughout most of the buildings to have a problem. Localized collapses actually occurred. All three buildings also were able to resist progressive collapse. In other words, they didn't fully come down. Okay, what is going on here? What about WTC 7? Why are we even looking at this? Well, WTC 7 wasn't struck by a plane, and it came down. It collapsed. So WTC 7 was a 47-story skyscraper that was built in 1984 and was part of the World Trade Center complex. That 47-story building collapsed at 5:20 p.m. near ground zero at 9/11/2001. Remember, 7 hours later, about 7 hours later. It was not hit by a plane, and it suffered minimal damage compared to other buildings much closer to the Twin Towers. The NIST report, that's the National Institute of Standards, claims that the building collapsed because of fire on the 13th floor, and that fire resulted in a significant movement of the support of column 79. And I'll show you where that's at in a moment. Now, I want to be very careful here and share with you, it's not my intention, it's my intention, quite frankly, to not have a point of view about what may have brought this building down. I have refused to read any of the literature to this point, except to prepare this presentation and to prepare a presentation for my students and to prepare the presentation for the quarterly report. I had to read some stuff. But technically, I'm not evaluating any of the publications that have been published yet. We are putting together our own point of view from a scientific point of view with my students to try to evaluate what may or may not have happened. And in order to do that, I cannot be influenced by either party. So in an attempt to make this as scientifically based as possible, we're putting together what we call a technical review team. And I've insisted on that before I took on this study. And that technical review team has no relationship to the funding agency. And their purpose will be to review the work that we do and then bring and criticize it. And then it's my job then to respond to those criticisms. And that'll be there before we release the material. So this information that I'm showing you right now has not been reviewed yet. But when it gets formally put out there made available to everybody, we're going to make this very transparent. And so part of the work that's being done right now by Robert back here in the back, who is with the journalism department at UAF, is filming and making sure that the people in this country are aware of what we're doing, why we're doing it, and we're going to have availability for anyone who wants to ask questions to ask those questions, and we will then respond and try to make this as transparent as possible. Once we start putting the work together, then we're going to read the scientific journals. We're going to evaluate the pros and cons, the evaluation of everything. So as I'm moving through here, please understand I'm going to try to be very careful about what may or may not have happened, and there was a lot of things I don't know. Here's 7 facts about the Building 7 that came from things that we've looked at, and so I have looked at this. If fire caused Building 7 to collapse, it would have been the first ever fire-induced collapsed building of a steel frame high-rise. So that's point 1. So that gives people reason to want to try to explore what may have occurred. Building 7, number 2, Building 7's collapse was not in the 9/11 Commission report. Number 3, according to a poll in 2006, 43% of the Americans did not know about Building 7. Almost 50%. Number 4, it took the federal government 7 years to conduct an investigation and issue a report for this building. There's about 2,355 plus architects and engineers, licensed architects and engineers that deal with high-rise buildings. Or maybe not all of them are high-rise buildings, but certainly registered architects and engineers that have signed a petition calling for a new investigation to the destruction of this building and the towers. Numerous witnesses say the possibility of demolishing Building 7 was widely discussed by emergency personnel at the scene and advocated by the building's owner. And Building 7 housed several intelligence and law enforcement agencies and the New York City Office of Emergency Management, Emergency Operations Center, and more commonly known as the Gohini Bunker. So let's kind of take a look at where Building 7 was. There's WTC 1 and WTC 2, and Building 7 is off on the side. If you look at a plan view of its footprint, each floor is similar. And so WTC 7 is not a rectangular building. It's got a wider section at the top in this drawing than the bottom. And the original footprint is over part of the Con Ed substation. So that station was already there, and this building was built on it. One of the things I am looking at that to my knowledge others have not looked at is whether there was a problem in the foundation. So I'm trying to do my best to try to get the information to address that issue. This picture shows us different elevation views, north, south, east, and west. This view shows a cross-frame system of the exterior and kind of gives you an idea. This is WTC 7 again. The global tower model for WTC 7, a viewpoint from the southwest. So what we're doing is we're putting together what we call a virtual model of this building. And so we start off by looking at it from AutoCAD. This is a reporting record of the failure. Background: at the end of 2008, NIST published the final official report on the destruction of WTC 7 and the third skyscraper totally destroyed on 9/11. Discarding earlier official hypotheses and based on no physical evidence, as no metallography could be carried out because no steel was recovered from the WTC 7, the Institute claimed that ordinary office fires resulted in an extraordinary event. The skyscraper's total symmetrical destruction, which progressed at complete freefall acceleration for over 2 seconds are the span of 8 floors. So the point is, I'm not advocating one idea or another, but here's what actually took place. So you can see that it came down almost vertically. So what happened? WTC 7 fell on an average of 7 floors per second, 47 in 6.5 seconds. 1 second after the onset of the collapse, the speed of descent was almost 10 meters per second. After 2 seconds, it was 20 meters per second, and at the end, about 60 meters per second, or over 200 kilometers per hour. According to analysis by Frank Legge, who's a PhD, the rate of descent of WTC 7 closely matches the rate of gravitational freefall, which, combined with the uniformity of the descent throughout the breadth and length of the building, would tell you that if that was true, there was no resistance to the fall. And so that bears a reason why I'm looking at the foundation, because if that truly could have happened, then there wasn't any structure underneath as it began to come down. So architects and engineers for 9/11 Truth have requested a separate scientific evaluation of the failure of the building WTC 7, and here's my approach. We will attempt to eliminate the types of failures that were not possible. I don't know if we can find out what brought this thing down, and I've told them from the beginning, I don't know that I can. But I think what we can do is to eliminate those things that could not have happened. And that leaves some things that could be left. So anyway, we're going to try to evaluate what could not have happened. We have requested a technical review committee that will be in place to critically review our work. And I'm not only looking at that critical review team, but the committee will consist of experts in metallurgy, materials, fire engineering, structural high-rise buildings, architectural high-rise buildings, professors in structural analysis and forensic engineering. My point is, we will try to get the best to review our work. And it will not necessarily be in the US. I'm going across the world, if necessary, to get the best that has an unbiased view. The best we can find. My approach for this study will continue to be the following. We will use 2 computer structural analysis programs. One of them is SAP 2000, which we have at the university, and the other is Abacus. Abacus is a very sophisticated program, finite element program, that enables you, if you don't have everything in it, you can write software and attach it to it, which is pretty sophisticated. For those that do very, very sophisticated work, Abacus is one of the top programs in the country. And so that's why we've chosen it. We are taking this building, and keep in mind that it's not rectangular, and so we're taking 2 floors at a time and evaluating the response of those 2 floors. So, let's see, where am I at on time? So I have what?
You have about 12 minutes.
12 minutes. I'm in good shape. So 2 floors at a time will be input in AutoCAD, and we're doing that. We've already got 2 floors. We have a lot of floors already in, and the files will be checked against structural erection drawings for accuracy. These AutoCAD models will be used to examine 2 floors at a time using the 2 programs SAP 2000 and Abacus. So let me tell you how I'm doing that. I have 1 student putting the AutoCAD drawings in from the steel structural erection drawings. It's not easy. Very difficult. I'll show you in a moment what I'm talking about. He then takes those drawings, and my other student then makes sure that what he's done is correct. Then that drawing then is used. It's electronic media that represents what that floor looked like. We then import that into SAP 2000, and we import into Abacus. We then run situations on that floor using the 2 different programs. And if we can't get a corresponding rate, we don't have models that represent the behavior correctly. So as a means of quality control, I'm having both students check each other's work, and then I check the 2 students. So as a quality control, to ensure that we are doing everything right, and we have a model that represents the building, we're taking 2 floors at a time, and keep in mind there's 47 of them. They're similar, they're not identical. Models prepared by these 2 students will be developed using both programs, SAP 2000 and Abacus, and we're conducting what's called a linear analysis initially. Then I'm going to bring in another program called SolidWorks, and I'm going to look at the elements where we're connecting the beams and the columns together and get an understanding of how they respond under load and develop what we call MFE curves. So we're going to develop it using a nonlinear component. So if the building begins to fail, we can simulate how those members, how those connectors, how those bolts, how those wells actually responded under those loads. We're going to examine the structural stiffness of each one of those floors, 2 floors at a time. And the reason I'm trying to do that is I want to know, are there unusual events in this building that nobody really knew about? Is one floor different than another, and how much? So I'm trying to get a handle on that. We're going to look at the response by fire. We know that Nice said there was a fire, but it burned for around 7 hours, but it's our understanding that the fire department came and looked at it and left and said it was not a big deal. And so why was there a problem? So anyway, at this point, there's more questions than there are answers, and maybe some of them are not even accurate questions. So the response caused by fire will be examined. At this point, I don't even know what the fire may have looked like. Okay, so they say there's a fire in this corner. How big a fire? How much was, what kind of fire? Was there fire retardant? Were the sprinkler systems on? We know there was fire retardant. I don't know what kind of fire retardant yet. I'm looking for that. I also know that there were supposed to be sprinklers in it. There was supposed to be water on certain floors, but we also know that there was a lot of water used on Trade Center 1 and 2. I don't know at this point just how much sprinkling capability was there at that moment. So there's a lot of, I have more questions than I have answers at this point, just kind of give you an idea. Our objective is to rule out the impossible scenarios that could have collapsed the building and test the official NIST reports. Okay, that's where we're at. And this is the beginning. So fire, I'm not going to read all this. Fire resistance is, with a steel structure, is a big issue. And so this was a fire endurance of steel that was published by others. And it refers to various pieces of the National Institute of Standards and also of the different hypotheses that different people have and so forth. In December 2007, it was acknowledged in the advisory committee meeting of the NIST that the fires in WTC 7 were ordinary of office fires and burned out in a given location in about 20 minutes. In such a short time, the temperature of fire-protected steel members would have maxed out, probably around 400 degrees Fahrenheit. If that's true, then there wouldn't have been a problem. So there's something else here that doesn't jive. Tower 7 was one of the 7 buildings at the World Trade Center complex in New York. The skyscraper was 610 feet tall, 350 feet away from the Twin Towers. So that's about a football field away. As well as the housing offices of leading financial companies, Tower 7 also had some unusual tenants: the Secret Service, the CIA, the Department of Defense, and the Office of Emergency Management, which would coordinate any response to a disaster or a terrorist attack. So the WTC 7 floor fires, NIST determined that there were fires on floors 6 through to 13, except floor 10, and also on 19, 21, 22, 29, and 30. This is kind of gives you an idea of that building from the side. This is kind of a picture of some of the fires on the east side of the building. Another picture on fire in a closer view. This kind of gives you the idea of where floor 13, where they think that everything started, and that's where the fire was located. And you'll note that the column of interest is that little circle, column 79, which they said caused the entire collapse. What we did is we took those floors, 47 floors of framing, planning, view, structural detailing, and this is the typical floor plan we had to look at. Yeah, I got it. We took that and created that into AutoCAD. We then put the floors 12 and 13. We started with floors 12 and 13. And we then looked at the roof framing plan. We put them in SAP 2000 and Abacus. What I'm doing now is I told you what I was going to tell you. Now I'm telling you, okay? Now I'm reviewing what we did. We're also looking at these floors from a composite and a non-composite point of view. Composite meaning the concrete and the steel work together. Non-composite meaning they're separated. I want to see what the differences were. Results from SAP in 2000 and Abacus are close to the results by hand. I had my students actually test a very simple beam and compare the two programs and make sure that we were modeling this correctly. Then this is floor 12 and 13 on SAP 2000. In other words, this is where we brought in the AutoCAD. This is the result of that AutoCAD. This is the SAP 2000 in plan view. This is what it looks like in 3D. This is a deflection under self-weight. I might point out that this is highly exaggerated. Floors 12 and 13 with released joints. And basically what I'm saying is I'm not letting the connectors resist load. Then we took a deflection again with those released joists. Whoops, back up. I want to show you that this is 10 floors put together. We currently have 30 floors put together. We don't have all 47 yet. Software modeling, we're using SAP 2000 to examine the accuracy, compare everything. So we're using Abacus to simulate the WTC 7 collapse. What we're doing now is looking at the fires. And so I'm going to be sending Zilli Kwan, who's going to be doing his work on fires of structural steel. I'm going to probably sending to some of the fire research labs and see if we can simulate their testing. If we can learn how to test and evaluate steel, what's not been done in the past is look at how a structural steel system responds three-dimensionally. When I say three-dimensionally, I'm saying typically walls are tested. That's two-dimensionally. They're tested without load. Then they're tested with load, as bearing walls and non-load bearing walls. And you all that have worked in construction industry know that a wall panel is tested, and if it can stand a 2-hour fire, then it passes and you can use it. And when you put a load on it, it may not be able to do that test, and you do something else to it. And that's paid for by the industry. And then it gets accepted, and then you put it in your buildings. But that's not three-dimensional. In three-dimensional, you have structural steel framing in many different directions. And even though it may or may not be fire resistant and may not have sprinklers, if the fire is over here, the other steel may not be as hot. And so what does it redo really when the fire propagates? Does it respond and everything fall down? Well, I'm not so sure. So at this point, we're going to try to get a handle on how it truly responds. So we're going to look at the fire, try to see if we can model fires. We're going to try to see if we can do a heat transfer evaluation of how the steel responds to those fires, if we know how to model the fire. And then we'll look at the change in material properties with temperature. We know it changes at very high temperatures, and it doesn't able to respond as well. And then we'll look at its nonlinear response and then evaluate the potential for structural stability, collapse in other words. So we're looking at stiffness values at each floor. I'm loading them both horizontally, in both horizontal directions separately. I'm also looking at its ability to rotate, see if it's actually going to come straight down, if there's some issue going on. We're looking at all those different kinds of things. We're looking at deflections caused by those loads. We're looking at moment releases of the connectors and so forth. So this kind of gives you, and we're looking also at the loading point, column 79. If I remove that column, what happens to the building? That's what I'm doing right now. What happens if I remove that column? Is there a problem or is there not? You know, so this kind of gives you an idea, oh my God. So there's some kind of deflection out here, but it isn't coming down yet. So, okay, so what's going on with all that? So here's column 79. Here's some of the deflection stuff that we've done. We've looked at some preliminary studies of this. We don't have a full evaluation of it yet, but anyway, that's where we are, and I thank you for coming.